Okay, we gotta solve this mystery. How does the graph of f of x, x cubed, compare to that of g of x, x cubed plus 2? Well, let's plot points. Okay. First point, this is x, this is y. -3, -27. So that means left 3, 1, 2, 3, down 27. 1, 2, 3, 4, 5, 27. So that's all the way down here. We'll say it's there. Second point, -2, -8. Left 2, 1, 2, down 8. Here. Third point, -1, -1. Left 1, down 1. 0, 0. 1, 1. Over 1, up 1. 2, 8. Over 2, up 8. And 327. Okay, so it's up there. Connect the dots. This is the graph of f of x. All right, what about g of x? We want to do the same thing, but our pairs have the first coordinate, the x coordinate here, the y coordinate from this column for g of x. So first pair is going to be -3 with -25. -3 over here. And we didn't go quite as down as far as we did last time, but almost. Okay, -2, -6. -2, down 6. Again, we're not going quite as far down as we did last time. Third point, -1, 1. -1, +1 means we go up in the y. Fourth point, 0, 2. So 0 means don't move at all, and then go up 2. So right there. I'm not going to label it. Next point, 1, 3. So right 1, up 3. Okay. Then 2, 10. Right 2, up 10. All right. And then 329, that's going to be way up there. I won't even try drawing it. Okay. So now we're going to connect the dots. Now the question is, how does this blue graph, g of x, compare to the red graph, f of x? Well, if you'll notice, each of these y points for g of x were 2 more than the corresponding y point for f of x. And when we go to plot it, it means that each of these points on the g curve is 2 units above the corresponding point on the f curve. Okay? In other words, g of x is a vertical translation of f of x. So if you add +2 at the end, you move the graph up by 2. What if I subtracted 2 instead? What if I had, an h of x, which is x cubed minus 2? Well, without even doing the t-chart or any computation or nothing, I already know what the graph of this looks like. There's a -2 at the end. That means I take the original graph, the red graph, sometimes we say parent function, and I shift it down by 2. So I would take every single point on the graph and shift it down by 2. And then I would connect the dots, and I would get a graph. Something like that. Okay. Now what if I had k of x is x cubed plus 10? What does that look like? Well, that would take the original graph, the red one, and shift everything up by 10. So we'd be going through this point, we'd be going through this one, shift everything up by 10. Maybe it'll look something like, nope, never mind. Something like that. Nobody's perfect. Anyway, I think you get the main idea. If you add things at the end of a function, you shift the graph up by the corresponding amount. And if you subtract them, you shift it down.